So for question 11, we have a proton that's being accelerated from rest in a particle accelerator. And it was mentioned that it travels in a very nearly circular path. So simply put, you can just assume it is circular and then use all the circular motion equation to solve the question. And then it was also mentioned that the diameter very gradually increases over many revolutions to a final value of 1.2 meter. So this is where you need to make a mental note that the 1.2 meter referred here is actually a diameter. Okay, so this is actually a diameter. So it is actually useful for you to assess here and then write down r equals to 0.60 meter, because radius is what we normally use as the quantity in any circular motion equation. Like A is equals to r omega square, V is equals to r omega. So radius is more oftenly used. So by the fact that 1.2 meter is actually diameter, some student will carelessly substitute 1.2 meter into the equation if they didn't make the mental note that this is actually diameter instead of radius. And it is also mentioned that the proton reaches a kinetic energy of 5.0 times 10 to the power negative 13. We need to calculate the centripetal acceleration. So, like I mentioned, centripetal acceleration A is equal to r omega square. And we do know radius is actually 0.60 omega square. So now we need to solve omega square in order to solve A. So to solve for omega square, we can use 5.0 times 10 to the power negative 13, that is the KE. So KE is half m v square equals to 5.0 times 10 to the power negative 13. We do know we can have the value of m is being given in the question 1.67 times 10 to the power negative 27. So basically half times 1.67 times 10 to the power of negative 27. And then to make v square into omega square, we can simply use this equation. So r square omega square. So v square can become r square omega square, and that would be equal to 5.0 times 10 to the power of negative 13. And we also know that r is actually 0.60. So this is actually 0.60 square. So we have all the values into the equation. We can simply solve for omega square. So omega square should give you a value of 1.6633 times 10 to the power of 15. Okay, so substituting this into the equation, we will have solved for acceleration 9.98 times 10 to the power of 14 meter per second square. Okay, so this is one way we can solve for centripetal acceleration. In our typewritten solution, we have used another way. So the formula we use, instead of r omega square, we have used A equals to v square over r. And this is equally sensible because we have k equals to half mv square. So we can actually make v square the subject, okay, which is 2ke over m, without converting r omega into the equation for v. So this is equally viable. So just substitute the v square into the formula here, and we will get A is equals to 2k over m over r. And then pressing the calculator, we will get the same answer. So it is really up to you that which equation that you feel more comfortable. So both are equally viable. So there you go.